Okay, vertical resistor motion part 3. All right, so let's have a look at question 7 from exercise 6E, I think. So this question says a particle of mass m. Okay, let's just highlight all the important information. We've got a particle of mass m falls from the rest. Okay, so it's going from the top to the bottom. From a point O, so the top point is going to be a O, a medium whose resistance is mkV, so we have a resistance of mkV. K is the positive constant, V is the velocity at the time t. So for the first part, I prove the terminal velocity V is V equals to G over K. Now terminal velocity is when the acceleration is equal to 0. So this is something. So basically, terminal velocity is when the object hits the ground, okay, and the acceleration is equal to 0. So if you think about terminal velocity is when the acceleration is equal to 0, vertical acceleration equal to 0. So that should be quite easy. So the first step to do this question is draw a diagram, find the equation of motion by writing the equation of motion down, and then you're letting y double dot equal to 0. Then hopefully you can find out the velocity is equal to g over k. All right, so we've got a particle, an object going downwards. There's a force that goes down. The gravitational force is mg, which is going downwards as well. Next is there's a resistant force that goes up, which is mkV in this case here. All right, so the equation of motion is just going to be F equals to positive mg minus mkV. All right, and then we can change the F equals to ma is equal to mg minus mkV and divide both sides by m. Acceleration is equal to g minus kv. All right, now we want to find the terminal velocity. So the terminal velocity happens when the acceleration is equal to 0. So please remember this all the time. Acceleration equal to 0. So therefore y double dot is equal to 0. In this case, we can just write acceleration equal to 0 here. All right, so 0 is equal to g minus k v little t. That becomes, or indicates that's the terminal velocity. So vt is equal to g over k. Okay, so that is just the first part of this question here, which is pretty straightforward and easy. Next, prove the speed at time t is given by this formula. Now, we want to find the speed at any time, and if you pay attention to this one here, it's the time and a velocity function. All right, so all we have to do is think about, okay, start from here, where you need to get time and velocity function. That's what we need to do, okay? So part 2 is actually pretty easy, or it's actually part A, I. So A, I. That's part AI, yes. All right, so we know acceleration is equal to g minus kv. I want to change that into the vt function. All right, remember vt function. So therefore, we need to change that into dv over dt, and that's g minus kv. So that should be quite easy, straightforward for this question there. All right, and we need to reciprocal both function here. So dt over dv is equal to 1 over g minus kv. And integrate both sides. T is equal to integrate 1 over g minus kv dv. So T is equal to minus 1 over k ln absolute value g minus kv plus c. Okay, so we need to find out what's the c value. All right, when t is equal to 0, the initial velocity is also equal to 0 as well. Okay, so when t equals 0, velocity equals 0. If you do a substitution inside, so 0 is equal to negative 1 over k ln g minus 0 plus c. So c at the end is equal to 1 over k ln g. All right, so that is what is the value of c. All right, once you get c, you can actually find out what is the value of t. Now you can also use the method I showed you last lesson when you don't need to find the value of c. You can just integrate, use the definite integrals to do the question as well. So it's up to you. Whichever way you find it's easier. Personally, I believe finding a c is a bit annoying. As you can see, I need to find a c, I need to substitute the c back into the function, and then I need to substitute the value again to find the final value, which is not ideal. All right, anyway, so t is equal to 1 over negative 1 over k ln g minus kv plus 1 over k ln g. All right, and I think let's see what this question asks us to prove. Now, the question asks us to show that the speed at the time t is given by this formula. Okay, so in that case, that little v here is the terminal velocity. Okay, so I need to also replace the function in terms of terminal velocity as well. All right, so I guess what we need to do here is we need to making a v as a subject. That's the first step that we need to do this question. So we need to let t equals to 1 over k, factorize it, ln absolute value g over g minus kv. All right, and then we need to make v as the subject. Okay, so how do I make v as a subject in this case? Move the k over. All right, let's see. How do I make v as a subject? Okay, all right, that would be in terms of, okay, so times everything by k, both sides, that gives you tk is equal to ln g over g minus kv. All right, so that's 1 over tk, or tk to the power of 1, is equal to ln g minus kv over g. So what I did here is I switched these two around. So I found the reciprocal of these two by putting a negative in front of here. All right, this is just using the log laws. All right, so that gives you e to the power of 1 over tk, okay, is equal to g minus kv over g. Okay, so g e 1 over tk, okay, and that is equal to g minus kv. Right, so kv is equal to g minus g e to the power of 1 over tk. Okay, all right, so once we finish this, all right, then we can divide everything by k. So g over k minus g over k e to the power of negative tk. All right, at the end, we can obviously take the g over k outside, factorize it. So we get 1 over 1 minus e to the power of negative kt. All right, and then remember from the previous question that g over k is v, okay? So therefore, we can now replace that by the terminal velocity. So therefore, that gives you terminal velocity, or the velocity in your function in terms of time is equal to terminal velocity times by 1 minus e to the power of minus kt. Okay, so that's how you do the second part of question A. It's not that hard, to be honest. As usual, the process is just be able to change the equation of motion from one to another. Okay, so now let's move on to question B. Now, identical particle is now projected upwards from O with an initial velocity u. Okay, so project up with the same median. Okay, so both particles begins their motion simultaneously. Right, prove that the second particle reaches its maximum height at t equal to that. All right, so the maximum height is when v equal to 0. So this is again a vt function. All right, so we need to find the time, and then prove that the speed of the first particle when the second particle reaches the maximum height is given by this function here. Okay, so with this question, the first step we do is, as usual, we need to find the equation of the motion. This is always the most important part. We need to find the equation of the motion. So question BI. Okay, so the equation of motion of the second particle or second object, all right, is given by this time. Now this time we have the particle that's projected upwards. So we have two motion that goes downwards, the resistance and also the gravitational force. So therefore the force is equal to minus mg minus mkv. All right, and then ma is equal to minus mg minus mkv. So acceleration is equal to negative bracket g plus kv. All right, but remember we still need to find the time, so the vt function here. So as usual, we find the vt function, we need to change the acceleration to dv over dt is equal to minus g plus kv. Okay, find the reciprocal of both sides. All right, and you can integrate these. All right, so this time I'm just going to show you where I can use the definite integrals to integrate, so we don't have to actually find out what is the value of what is the value of c. So in order for you to do that, you need to actually write down dt here. All right, so again, if you think about it this way here, when t is equal to 0, the particle is at this level here. When time is initially the particle is actually still on the ground, so the velocity is going to be the initial velocity. Okay, so when t is equal to 0, the velocity is equal to u. All right, there's an initial velocity here. I think the question tells you the initial velocity is capital U here. All right, and so when t is equal to t, the time, any time, and I want to find out what is the time when the particle reaches the maximum height. Particle reaches maximum height when the velocity is equal to 0. Okay, so to do this, now it's very easy. We can just integrate both sides, and we can switch this around. So that becomes u and 0, just because we have a negative in the front. So that gives you 1 over k plus g plus kv dv. So t is equal to 1 over k ln absolute value g plus kv. All right, and then you can integrate from 0 to u. All right, so doing this method here, you don't have to actually find out what is the value of c. It's just slightly easier. So in this question, I actually show you both ways of doing it. So that's g plus ku minus ln g. So t is equal to 1 over k ln absolute value g plus ku over g. We can remove the absolute value since everything inside this logarithm is positive, so therefore that becomes the answer here. That's not absolute value. All right, so that's it. So that's what the t equals to. Let's see what's the answer for the question. Yes, that's what the question asks you to actually prove. All right, now we need to prove that the speed of the first particle when the second particle reaches its maximum height is equal to that. Now we need to find the speed of the first particle when the second particle reaches its maximum height. Okay, since we already know that when the second particle reaches maximum height, it means the velocity is equal to 0, and the speed of the first particle is actually given by the previous equation, which is that equation here. So we can actually do some substitution to work out the answer. So it shouldn't be a hard question there this time. All right, let's do a substitution. It's mainly just substitution. All right, so question B, part 2. All right, so for the speed of the first particle that we know, that we just call V1 as the first particle, is equal to V terminal velocity times by 1 minus e to the power of minus kt. All right, that is the speed of the first particle here. Now, if you pay attention to that, this is negative kt. I just need to find out what's the value of t to find the velocity. So the time it takes by for the second particle to reach the maximum height is when t is equal to 1 over k ln bracket g plus ku over g. That is the time for the second particle to reach its maximum height. So then all we have to do is substitute this time here into this, all right, and then we should be able to get answers without any problems, all right? That's what we need to do. We need to find the time, find the velocity when the time is equal to 1 over k ln bracket g plus ku over g. All right, so let's do that. V1 is equal to Vt times by 1 minus e to the power of minus k times by the t, and t is 1 over k ln. It's pretty crazy, this expression. So V1 is equal to Vt times 1 minus e. Now, negative k and the 1 over k cancels out. And then this negative can be moved inside in the logarithm here. So that gives you ln bracket g over g plus ku. All right, so that gives you V1 is equal to Vt times 1 minus. Now, this expression, that e and log base e, can be, deleted or cancel it. All right, this is just simplification. So these two can be cancelled. All right, in that case, you will end up with just G over G plus KU, the power. All right. Okay, all right. So when this is done, now you just have to simplify what's inside, and hopefully that gives you the answer of the question that's required. But the answer of the question is in terms of U, capital V, and capital U, capital V again. All right, so it's going to be a quite difficult algebra to do. All right, let's see. So V1 is equal to VT. Let's have a look. All right, so what's the best? I'm just thinking about what's the best way of doing it. Okay, so I guess probably we just need to do it like, make the same denominator like this. Okay, all right, we'll probably just need to do it this way here. I don't think there's any other sort of shortcut to help us. All right, so let's just continue to do that. And in this case here, we can actually cancel a G and a G here. So we can cancel these two. And we end up with V1 is equal to VT times by KU over G plus KU. All right. Now, what we need to do here is remember the velocity. I think the terminal velocity is equal to G over K, right? Yep. So the terminal velocity, so Vt is equal to G over K. I just need to find a G over K somewhere. All right, how about V1 is equal to Vt times by K capital U over G over K. If I take the K outside, factorize the K outside, that gives you G over K plus capital U. So Vt Ku over G over K is just Vt, so therefore that gives you K bracket Vt plus U. All right, and then we can cancel the K and K, and then we, instead of writing Vt, we can just write V, because Vt I just write on terminal velocity. So Vu over V plus U. And that's what the answer is. So yeah, as you can see, mechanics, it's like that. Even you know how to do the previous part of the question, but then you still need to have a very good foundation of the algebra in order for you to actually solve the question. It's not that easy. Algebra is the foundation. Let's see the answer here. Yep, that's what the answer is equal to. All right, so UV and then over U plus V. All right, so question 7, another example of vertical resistant motion. I feel like this is enough for these 3 questions to be covered, in this series of lessons. The remaining question will be very similar. It's all about just show a certain formula, prove certain formula, but again, the most important thing is be careful, which motion is is that going up or is that going down, and make sure that you actually know what is the equation of motion and how do you change from one equation to another. All right, thank you.